Question 7. Find the limits of this function as x tends to infinity. One, we have the function inside as this. Okay, and the power is what? 2x squared. So the first thing we are going to do to solve this question is to, let's make this one, let's call it y. Let y be equal to what? 1 plus this one. Make it that. That's step 1. Then the next step is to take the length of both sides. And this will be equal to what? If you apply logarithm rule, this power will go to the front. So we have 2x squared ln 1 plus 1 over 3x squared. So that's what we have now. This one, don't forget that ln is equal to logarithm to base e. So y will be equal to what? E to power this. And this particular question, this particular expression is the same as what? As this. Okay. So but the moment you put this one back, exponential of that will give you back your question. So what we are going to do now is to take this one, the power here, take this power here, let's call it L, and take the limits of that. Limit as x tends to infinity of this power. So do your direct substitution. If you do that, it's going to give you, put your infinity there. So this 1 over infinity, that's 0. So ln 1 is what? Is 0. So it's going to give you 0 dot infinity. And when that happens, we're going to play with this and turn it to, want to make sure that at the end of the day, we're having either 0 over 0 or infinity over infinity. So let's work on this. So this will be equal to limits as x tends to infinity. And that will be, these two can go outside the limits. So we have ln of this function all over 1 over x squared. Don't forget that x squared is the same as 1 over x squared. So that's what we have done there. Can you do your direct substitutions? If you do that, it's going to give you, this is 1 over infinity, that's 0. This numerator also, that's 0 over 0. So that's what? Indeterminate. So that's the indeterminate. Is that the end of the road? No. So when your limit is giving you either 0 over 0 or infinity over infinity, so apply L'Hopital rule. What that means is that we are going back to our function here and differentiate the numerator and differentiate the denominator. That's the meaning of L'Hopital rule. So, and that will be equal to 2 limits as x tends to infinity. Can you differentiate this one? The numerator, that will be 1 over the function times derivative of the composite function, derivative of the inner function, and that will give us, let's work on that. I have the constant here, 1 over 3, and I have here 1 over x squared, which is x to power minus 2. So if I differentiate this one, I'm going to have minus 2x minus 3. So which is the same thing as what? Minus 2 over what? Over x3. So here it's going to be what? Times minus 2 over x3. All over the denominator, if you differentiate that, you have 1 over x squared. That is what? X to power minus 2. And that will be equal to minus 2 times x to power minus 3. If you differentiate x to power minus 2. So you have minus 2 over what? X3. So that's what we have. When you apply L'Hopital rule, you're not using quotient rule, because I know that we have a quotient function here. You're going to differentiate each of them, the numerator separately, the denominator separately. That is the what? That is the meaning of what? L'Hopital rule. So that's what we have done in this case now. So this will give me this one. Flip it upside down. So you have this. So minus 2 cancel itself. 3 also cancel itself. This 3 here can go to the front. So I have 2 over 3. Limits as x tends to infinity. 1 over 1 plus. So we have this now. Then we can do your direct substitutions. If you do that, this will give you 0. So 1 over 1. So your answer is what? 2 over 3. Come back to this place. Okay. Y is equal to what? E to power what? This is what we call the L. And we have a value for that. So that's 2 over 3. And your Y is your what? Is your what? Your Y is that. So this implies limit as x tends to infinity of that question equal to what? E to power 2 over 3. So that's that on these aspects. Kindly click on the watermarks on this video and subscribe. That is the only way to advance this channel. Click on like button, okay, and begin to type your comments. Click on like button and make your comment true. Finally, share the links of this video on all your social media platforms. Thank you for doing that.